Okay, let me see. So that's the circle question, right? You're asking.
That decision tree. No? So the Sagarika wants to know about that
It's
decision
not
tree.
a decision tree, it's a logistic regression, right?
Wasn't it the decision tree that I posted?
That question, so that is logistic regression. Basically, that EXP. But anyway, let me share the solution and based on that.
Derive the equation of the decision tree boundary for logistic
No,
regression.
no, not decision tree, decision boundary. That is
Decision boundary, yeah.
okay. So it's basically logistic regression. Okay. So logistic regression output will be either 0 or 1. Okay. That is clear, right? So even if we substitute the values that are given here, so you will either get, so if you get value less than 0.5, we will classify it as 0. If we get a value, final value, y value greater than
Not,
0.5,
Rao, I'm sorry, it's not clear for me. Can we make it big or
now is it okay?
no message?
Okay.
Sagarika,
So
to follow him, what you saying? Do you have any
Yeah,
doubt?
yeah. Now, yeah, I can see it properly. Yeah.
okay. So basically, you see, this is the equation they have given, right? 1 by 1 plus exponential minus theta x. Okay.
Mm-hmm.
So ideally, the logistic regression equation is 1 by 1 plus e power theta transpose x. So theta is weight, right? The angle between, so every, if you have two, multiple dimensions, every dimension will have some angle
Hmm.
where we
Slope.
find out, and that is what is the theta values will say, and which we will multiply with the x values. So x1, x2, x3 are the variables in the logistic regression. Okay.
Mm-hmm.
So, and when we substitute some x1, x2, x3 values, right, and w are weights. Okay, we continue to change the weights until the logistic regression properly fits all the values, and we get a confidence score of 80%, 90% that we get a result, right, in the confusion matrix.
Mm-hmm.
Okay, we will tune those weights basically. X1, X2, X3 values are the table that they will give. Any machine learning algorithm we take, we have a table. We may have categorical variables or continuous variables and all, right. They are the X1, X2, X3 for us.
Mm-hmm.
Okay, and these weights is what we tune, algorithm will tune to fit the logistic regression line.
Mm-hmm.
So let me just show some logistic regression examples. Okay, so the curve will be like this in general. Okay, so and anything left side will be, this region will be 0. That means we will classify it as 0, and this region we will classify it as 1. Means proper classification. Okay,
Mm-hmm.
so that is how it is. So if you take this question also, we can substitute these weights in the equation. X1, X2, X3 are also given to us. What is x1, x2, x3 is this. So minus 2 point, minus 2 comma 2, 6 comma 6, minus 5 comma 5.
Mm-hmm.
Okay, so weights are already given here.
Can
Minus
you
1,
zoom in a little bit?
yeah.
Yeah.
So these weights minus 20, minus 2, 4, 1, 1 is already given in the question, right?
Yes.
These are the weights, the initial weights. Okay.
Mm-hmm.
So generally how the machine learning algorithm will do is these weights and x values will be substituted, and we have a training set, right? Training set will say it is yes or no for us. We know the result also, correct?
Mm-hmm.
We know the result also. So what will happen is we will initially some weights will be chosen, and we anyway know x1, x2, x3 all these values which is in the table, and using that we will try to find the probability. So logistic regression is all about the probability, which will vary from 0 to 1. Okay, when we substitute those weights, you get a y value. Y value should match with the actual result.
Mm-hmm.
Okay, so okay, for example, let's take some logistic regression.
So there is just one question like for each point of x, we are taking
Some problem we will take to understand.
is it like for each value of x, we are taking one weight and trying to get the y?
Yeah, so each variable will have a weight. So we'll tune the weight such a way. So if you don't want to consider weight for some parameter, you can make it as 1. Uh, okay, classification problem. So these are all giving. Okay, let me take some table. Did this give anything? Okay, yeah, let us say it. Okay, so you always in the logistic regression you always have binary output, right? It is 0 or 1. You see, it is 0 or 1. Any logistic regression you take. So when we are expecting the binary output only, then we will consider a logistic regression. Okay, these x1, x2, x3 values are user ID, gender, age, estimated salary. Okay, obviously user ID we will truncate it off because that will not play any role because it is
Correct.
generally an auto increment number, right? We won't consider that. So, but in general, initially when you are considering a problem, user ID is also one of the variables. So in the pre-processing, if you eliminate, you will eliminate. Finally, you find whatever variables are required to be considered in the algorithm. So these values we will consider and each will associate with some weight. It's a algebra, right? So we need to, this machine learning algorithm completely works on algebra. So what we will do is these kind of variables, we convert it to a scale, some common scale we will convert. So we know normalization, right? We do the normalization. Male we consider it as 0 and female we consider it as 1 or vice versa. Okay. And then age also we will bring it to some scale. Estimated salary also we will bring it to some scale, which is automatically happening in the scikit-learn or some library. But generally that is what will happen. So when you actually get to a number scale, then we have x1, x2, x3 values, and you initially consider some weights. Let's say in this problem, we considered weights to be minus 20 to 411, right? And they have given the equation also here. Okay. So how the x1, x2 values uh, will be substituted in this 1 plus e power theta x equation so that you get some y value. Okay. So if you get 0.5 greater than 0.5, we consider it as 1. That means classification to be yes. And if you get less than 0.5, classification should be considered as no. So that is how we find this equation finally. So is it clear about this is nothing to do with the question itself, but it is just a logistic regression, how to
Yeah, yeah.
understand.
So explanation is clear, but in this equation, how it is doing that, I'm not clear.
This equation. So now let's see. Okay, this is a tricky question. It's not directly related to logistic regression or something. So they have changed the logistic regression equation. Generally, if you see in the logistic regression, there won't be any x squares or x cubes and all these things. It will be the line considering all the attributes w1 x1 w2 x2 w3 x3 w4 x4 like that it will be in the general equation. So that is the theta transpose x, right? We will not say x square anywhere. But these people have given logistic regression. Let us say if theta is like this, if theta x equation is like this, how will the decision will happen? They want us to understand the crux of it. That's why they have changed the equation itself. So generally, if you see, let me show you the solution. So in this solution is like this. You will form a circle with 1 comma 2, and never in the logistic regression you get a circle. So in the logistic regression you will mostly have this kind of curve only. Okay. So this is the actually theta transpose x curve. It will be like this. Maybe it will bend left side or it will bend right side, whatever can happen, and even the angle can be changed of this, but the line will look like this ideally. Okay, but in this question, particularly, they wanted us to understand how the decision boundary can change if the equation changes. Okay, that is how you got this circle. Okay, now let's come back. Okay, now, so to solve this question, W0, W1, X1, W2, X2, they have given this equation, right? we just substitute this in the equation. Okay, so if you see minus 20, 2x1, 4x2, it is just a simple substitution of those weights. Okay, so for it to be classified as yes, we know definitely it has to be greater than 0.5, right? The whole equation, when it is greater than 0.5 only, we classify it as 0.5. So that means just take this portion. So take a case, okay, how the probability will change. If it is 1 by 1 plus some value, this is the one which is changing the total probability, right? If it has to be greater than 1.5, this exponent of minus theta x should be definitely less than 1. We can do the math. Okay, so take a case, let's say you have 1 by 1 plus 1, 2. Or, okay, take case, let's say 3, right? 1 by 1 plus 3, which will be what? 1 by 4, which is 0.25, right? So this whole equation, exp of minus theta x, let us say it is giving us the value of 3, right? So if it is giving value of 3, then it will probability will be less than 0.5. Okay, you got this one? Or so this is the only guy who is deciding the probability, right? So if it has to be greater than 0.5, exponent of minus theta x should always be less than 1. If this is understood, everything else in the question can be understood. So if the exponent of minus theta x is less than 1 only, then the probability can be greater than 0.5. Okay.
Is it
So
given in the question that that 0.3 that one is given in the question?
which one? Which 0.3?
0.3 should be greater than 0.3. That one.
This one. This is not 0.3. It's 0.5.
So that's
Yes, it's 0. No, it is not given in the question. But so that is the thing, right? If it has to classify, probability has to be more than 0.5. That is the logistic regression.
oh.
Yeah. So otherwise it will be classified as no. So how do you decide? Final output, this is not a linear regression, right? Not a continuous variable. It's a binary output, either yes or no. That's it. So yes or no, how do we decide? Based on the probability, probability is more than 50%. We say it can be classified as yes, and probability is less than 50%, it can be classified as no.
Oh, okay.
That is how we get to this equation.
How this exponential theta x is less than 1, how that line will derive?
How that line works is, okay, you try to substitute some values. Get that right? So let's say the entire equation exponent of minus theta x is giving you the value of 3. Okay, 1 by 1 plus 3 is how much? 1 by 4 is 0.25. So likewise, if you keep on substituting any value greater than 1, the probability is always less than 0.5. Even if you substitute 1, right? 1 by 1 plus 2 is what? 0.5. Not less than 0.5. So so when exponent of minus theta x, if it is less than 1 only, theta x can be greater than 0.
So like that only we have to go, right? Like we have to keep on substituting those values, and then only we'll. Okay.
Yes, perfect, correct. So that's why, so we never want probability to be less than 0, right? Probability is always 0 to 1. That is agreed, right? So that is why, so if exponent of minus theta x is always less than 1, then, so this is something to do with how exponent table works. So if theta x is greater than 1 only, the above condition can be satisfied. Okay, so that is how we get it.
Okay. So now we need to be clear on this exponent function, right?
Exponent function we need to be clear, and also we need to understand the logic of this 0.5 limits of logistic regression itself. We need to understand. From there only we derived this. Okay, this theta x. So now everybody, if understood, I'll move on. This is the crux of it. Then after that, it's a simple math. Okay, so theta x should be greater than 0. So we agreed, right? If it is agreed, theta x is already given in the question. You see, this is the equation. And then we know it has to be greater than 0. We simply substitute the values, and you finally get, if you simplify, you will get this x minus 1 whole square plus x minus 2 whole square greater than 25. This is the equation of circle. Okay, ideally circle equation is equal to 25, but since we are classification, whatever is in the circle will be classified as no, whatever is outside the circle will be classified as yes. Okay, so this is the 1 comma 2 is the center of the circle, and 25 is the radius. So if you see the next explanation, so you see the circle 1 comma 2 is the point boundary of the circle. Okay, that's why they have written 1 comma 2 in the circle, and then the center radius is 5. That's not represented properly in the diagram, but that is how, that is what it means.
How did we in the first place get to know that it's circle?
So this is equation, x square plus y square is equal to c square, right? So that is a circular equation. Let me, yeah, that's also math that we need to understand.
Okay.
This math formula has anybody given? A square plus b square equal to c square. So that is the circle formula, where c is the radius and a and b are the boundary points. Okay, let's see if they have given. Okay, they haven't given, but I'll forward that link, math link, how to understood that explanation.
Okay. Thank
So,
you.
so 1 comma 2 is the point and 5 is the radius. So that is how we need to understand this equation. So then, so this is what they ask us to do, the decision boundary. So 3 marks are given for this, and then the other 3 marks are given for classifying these guys, 2 comma 2, whether it is plus or minus. So then, so we have the circle equation, right? So we need to substitute x1 x2 values in the equation. If the equation is satisfied, then you classify it as yes. If not classified, you classify it as no. Okay, so this is just how to draw the circle. And now you see here, you substitute minus 2 comma 2, what will happen? So it's already substituted, minus 2 minus 1 whole square plus minus 2 minus 2 whole square, so 3 square, right? 9 is 9 less than 5 square is wrong, so that has to be classified as no, which is C0. Okay, this is understood?
Yeah, this is understood. But how can we like study the maths? Like in order to solve this question, there are kind of 2-3 concepts of math are used.
Yeah. Well, algebra needs to be understood very well. Yes, so that is what some questions. So the way they set the paper, right? So some questions are for experts and some questions are for basically who knows only machine learning, that kind of things, right? So who knows all these concepts only can understand. I mean, I didn't write this question, but so later, out of curiosity, when I asked some people, so they shared this explanation, and then yeah, I wanted to just share the knowledge. I haven't done this math part, so we have done only that substitution and find out 0 or 1. So I'll tell you the other way how to get 0 or 1, but this is how we can classify. One way is to classify this. You get an equation, and in that you satisfy, if the condition is satisfied, it is C0, and if you see here 6 comma 6 will be positive because 5 square plus 4 square is definitely greater than 5 square, right? It is outside the boundary, so it is plus. And minus 5 comma 5, so this will also, I think, satisfy, so it is also outside, so it is classified as C1. Okay, now, okay, I'll whether to validate this is correct or not. So what you can do is you can simply substitute x1 x2 values in this entire equation. Okay, so you know w0s and x1s, right? So you know You just in this equation, to be precise, you can substitute in this equation. Which one? This one. Don't worry about greater than 0. You just substitute in minus 20 minus 2 into x1 minus 4 into x2 plus x1 square plus x2 square. You get some exponent of e power. Okay. So let's say you get minus e power minus 22. E power minus 22 value is 0. 1 by 1 is equal to 1. So like that, you can just try to substitute w values and x values into the equation, and you will definitely get what we got in this third page. 0 1 1. That means e0. So you will get 0 for minus 2 comma 2, and you get 1 for these two, 6 comma 6 and minus 5 comma 5. Yeah. So I mean, even if you have done, let's say you don't understand this algebra and all these things, and if you have done just by substituting this in the w0 x1 x2 is substituted and finally found out the probability and you classify it as c0 c1, that should have given 50% mark. Yeah, the circle thing will give other 3, so that's why they mentioned 3 plus 3.
Okay.
Yeah. So I think that's what. Any questions I can answer, but yeah. So this was way beyond my expertise also to answer this. Yeah, but we got this.
Yeah, but thanks for explaining this very clearly, Rao. Thanks a lot.
Thank you.
Thank you, sir.
I just had one question related to ML. Is there anyone with ACI maker here?
Yeah, I am doing ACM maker.
How do I start studying? Can you please help me out?
No, actually, even by looking at the paper, it is like very difficult. The thing is, the same like ML, we need to understand, study concepts a lot to answer those questions. Okay, the
So
way.
how do I start? Like, I don't think going through the questions will help. And if you look at the textbooks, it is, I mean, I don't think it is, in a week, it is possible.
Correct. Meaning if you have to completely spend at least 4 5 hours a day, that's how we can complete at least half of the concepts. So definitely lecture notes will not help. Okay.
Yeah.